Here's an example of a mass spring system with no damping. Okay, so what's the system? Again, recall we have a mass sitting on a frictionless surface with the spring stiffness K and mass M. And the equations of motion are mx double dot equals minus kx, where x is measured from the unstretched length of the spring. So given mass M equals, let's say, 2 kilograms, and spring stiffness K equals 4 Newton per meter, and initial x of 0 equals 1 meter per second, x dot of 0 equals this should be 1 meter, and initial x dot of 0 is 2 meters per second. Determine 1, the natural frequency omega n of the system, by which we mean the angular frequency. Two, the time period of free oscillations, free vibrations. And 3, x of t given the above initial conditions. Okay, this problem is just using the expressions that we derived in the last couple of videos, or equivalently using the expressions given in the equations sheet for the course. So straight away, the natural frequency omega n is known to be given by, for a system like this, which is mx double dot plus kx equal to 0. That's the equation of motion. For a system like this, omega n is given by square root of k over m, and k is 4, m is 2, so you get square root of 2, and the units are radians per second or square root of 2 hertz. Because you can skip always the radians in these kinds of quantities. When it's angles per second, radians can be skipped if it's radians. Okay, so that's the answer. And then part 2, time period of oscillation. Is given by Tn equals 2 pi divided by omega n. Okay, so omega n is what's called the angular frequency. So 2 pi by omega n is the time period of oscillation. Again, that's an expression that we derived. And that's it. you just substitute 2 pi by square root of 2 or pi square root of 2. Now this expression is going to be in seconds. Okay. And then finally, 3, we are going to write an expression for x of t. The expression is just, we can directly use the expression that we derived, which is actually x naught cosine omega nt plus x dot naught divided by omega n sine omega nt. This is something that we derived. So we can just plug in those numbers. X naught is 1 cosine square root of 2t plus x dot naught is 2. So we have 2 divided by square root of 2 sine square root of 2t. That's x of t. So that's one way to write out the expression. Alternatively, we can just assume that it's a cosine square root of 2t plus b sine square root of 2t, and then try to solve for these things. So x of 0 is given to be 1, I believe. So we plug in x of 0 here, and you get a cosine 0 plus b sine 0 equals a, because cosine 0 is 1, sine 0 is 0, so that's equal to 1. So a equals 1. And then b, how do you get b? B you get by using the expression for x dot. So x dot of 0 is given to be 2, and x dot of t, you can differentiate this and go square root of 2a sine square root of 2t with a minus sign plus b square root of 2 cosine square root of 2t. That's the derivative of this quantity. And then we can plug in x dot of 0 equals 2 equals minus square root of 2a times 0, because sine 0 is 0, then plus b square root of 2 times 1, because cosine 0 is 1. So what we get is b equals 2 over square root of 2 or square root of 2. Okay. This is a equals 1 in meters, and b equals square root of 2 also in meters, the same units. And that's it. You've gotten the same expression as before. Cosine square root of 2t plus square root of 2 sine square root of 2t. So these are all correct answers. And that's it.